skills. Unfortunately, stirring the pot and sarcasm aren't in high demand. So I'm doing other things. I've been studying AI for a long time, and I'm particularly interested in artificial general intelligence. Unfortunately, I have not been able to find a lot of information that is helpful or that answers my questions. So I'm doing my own research. So to start out with, what would I want an AGI to do? I would want it to answer difficult questions in ways that I can understand, and I would want it to explain how it got the answer, and maybe even to explain what alternatives it considered and rejected and why. That's pretty demanding. Now, in order to do these things, it would need to have a great deal of knowledge about how the world works. If you thought about expert systems, you typically think about rule-based systems. If you think about a typical business application, you might say, well, there's an employee object, and the employee object has attributes, and usually those are facts. So we're going to need rules, and we're going to need facts and things like that. But most of the time, they're nouns, and nouns don't really do anything. What's really important in the world are verbs, processes, things that actually are doing something, and that's what we need to capture. So in order to do these kinds of things, the AGI would need to know a lot about physics and chemistry and the other sciences, about math and logic and problem solving and things such as that, as well as communicating in a natural language. Now, I'm only really going to address one of these issues. Now, an AGI needs to know how to structure all of this stuff. And so I'm going to talk about processes. And in order to do that, let me shuffle things around here and see if I can not smash my cat. Okay. I brought up a little process screen that I made up. So I want you to think about a process. I'm going to have a dinner party Saturday. So Saturday morning, I'm going to cook some soup. I'm going to cook some corn chowder, and I'm going to serve it to my guests Saturday night. So I want you to think about who, what, where, when, why, and how, and aggregate all of these things with the process of cook. Now, in a way, I think this is called chunking. Now, that's the computer term, not the Chinese food. So I want you to think about chunking. And on this form here, if you can see on the top left, I've got some options: who, what, where, when, why, how, and so on. And the first one is who. So I clicked on the little drop-down box here, and I said me. I'm the one who's going to do the cooking. Then the next item is cook. That's what the action is. The next object the next drop-down is what object. So I'm going to cook soup. And then the next one is what kind of soup. Then the next one is, where am I going to do this? In the kitchen. When am I going to do it? Saturday in the morning. Why am I going to do it? I'm going to cook this for later use. How am I going to do it? I'm cooking. What's the quantity? 2 quarts. So all of this is a part of the process. Now, every process typically has sub-processes. And this process of cooking soup actually has a whole bunch of processes. So I've listed 3 different processes there. Actually, you can see 4 different things there, but one of them has the other screen showing. So the first process is actually clean the area, and the second process is gather equipment, tools, and supplies, and then the third one would be prepare the ingredients. Now, these are very generic processes that would apply to a lot of different processes, but they happen to apply to this one here. So then I get to the actual third process, and this is actually about the 4th or 5th process. So that's where I'm finally going to get to where I'm going to say the process is cook, the object is soup, and the indirect object is for later use. Now, every process has a predecessor and a successor, except the first process doesn't have a predecessor, and the last one doesn't have a successor. So you would want to list all of these processes so that the inference engine, or whatever it is that the AGI is using, would be able to follow these processes from front to back without having to look up logical rules it's got all of this stuff, all these links already built in as far as predecessors and successors. Now, each process might also have a sub-process. So for example, in the cooking the soup, I have several processes. One is lift the lid, one is stir the pot, one is put the lid back in. Now, these could be full processes in their own right, but since they are so minor and since all the other variables stay the same, it's just a sub-process, and you really don't need to go into it any deeper than that. Now, in addition to these things, the who, what, where, when, why, and so on, every process takes energy. So in this case, the actual cooking requires me, human, to turn the knob, and then after that, it requires gas to heat and cook the stuff. So every process requires energy, and we should record that as part of the overall process. Now, also, every process has side effects, and all of the processes I'm talking about here, the side effects are insignificant. But if you talk about mining gold or uranium or fracking or some of the manufacturing processes that use really dangerous materials, the side effects can be so significant that in some cases, in many cases, it can actually stop the process from occurring. So there's a lot of businesses that simply cannot manufacture in certain areas because of all of the side effects. Now, in addition to these things, there are collateral processes. So if I'm going to have a dinner party, I'm going to have to clean the house. I'm going to have to set up for guests. I'm going to have to set up the audio entertainment and things like that. There are a lot of collateral processes that go along with that. Now, if we aggregate all of these things into, let's say, attributes, we'll call them attributes of this process, and we have processes at various levels, then we can combine all of these things and we could store them in a database that the AGI could access. That would prevent going through millions upon millions of rules trying to figure out what to do. This way it can go directly to something and say, I have a process here and I want to say, how am I going to modify this process? Well, maybe I can modify who does it, or maybe I can modify the energy that's used on it. So a strategy, the AGI could use a strategy to try to figure out how to change this process, maybe to improve it or to maybe even prevent it. So for example, if you had a bunch of drug lords and you said, well, we want to get rid of all the drug lords. Well, how could you do that? Well, the easy way, if you had a computer game, was go down and kill them all. But that wouldn't be socially acceptable. So another alternative would be, oh, let's make it unprofitable. Let's make sure that we attack their bank accounts so they cannot make a profit. And if they can't make a profit, then they're going to have to go off and do some other different evil things. So by knowing what all these processes are, you can attack who or what or where or the energy source or something else like that. And that would be a strategy that the AGI could use with these processes to solve various problems and answer questions. Now, there are an awful lot of processes that are very well known. If you want to, let's say one of these things might be an action, assemble a model airplane. Oh, okay, so I've got a kit with instructions. So all I have to do is follow the instructions. Well, you put all those things in the computer and later on it says, okay, I need to assemble something. Well, this is similar to that model airplane. So let's just use those instructions and see if they work. So these are processes that you could put into a computer, and that would help an AGI solve a whole bunch of problems. Now, I used an example of cooking soup. Obviously, an AGI wouldn't care about cooking soup, but it would care about fracking and nuclear proliferation and a whole bunch of other really important issues. And if it knew about these processes, it could help solve these problems. So I think processes and storing processes is one of the major keys into how an AGI, how we should structure a knowledge base for an AGI. Questions? None? Okay, goodbye.
Oh, I'll ask one. I'm curious in your graph, and it seemed like it was convenient. The form was convenient for entering the information about these steps. I'm wondering if the general structure that seems to dominate how these things tie together could be. I'm just thinking like a UML diagram to bring this into some context that we could
Well,
replicate and really poke at as to whether or not the process was this whole thing of the process over the process was correct.
yeah, well, that's I just created this thing because you know, this is sort of the second or third draft, and there's a lot more to go. But I'm actually, instead of working on this an awful lot more, I'm actually working on trying to validate this system in a different way by writing a program that will solve chemistry problems, first year chemistry problems. And so I've got all the elements and compounds on the left hand side, and I've got a bunch of elements and compounds on the right hand side, and I'll use various processes to either compose or decompose various things, or to do various other types of chemical reactions. So I'm trying to build all of that as a desktop application, and use the same ideas that I'm using, that I mentioned here, where I'm talking about processes. And so I'll go out, I'll use the process, I'll go out and gather some facts, I'll use some rules, and then I'll go back to the process, and I'll keep going through various processes. And I want to sort of prove the concept by doing all of this, first of all, in a chemistry thing, the first year chemistry thing, then a first year physics thing, and then I'll see what happens after that.